locally. That will be easy.
Okay, yeah, I keep admitting people, so yeah, so let's see. Okay, let me share my screen.
Yeah.
All right. Okay, everybody see my screen?
Yes, I can see it.
Okay, cool. Thank you, Kaja. Yeah, so yeah, thank you. So earlier we were talking about how we can use Karate DSL and how we can leverage it in your API testing. And Karate is really good that way. If you we have a lot of capabilities in that, we will probably talk in detail as we go down the session. So as I mentioned, like my name is Sai. I work with one of the IT services company. I work with Kaja. So we work with various clients, and so we thought like, okay, maybe we want to share what are the knowledge we have on the Karate. So with this, the first session will be a lot on the what is an API testing, what is web services, and how we can use this Karate API to test your API web services. All that we will probably talk in detail. So, so I keep getting some alerts. So just bear with me. I have to admit people, in the middle of the session. I hope I won't get that alerts after 5 minutes or maybe after some time. I expect the audience is there in the room. Yeah, the meeting room. Okay. So what is an API? So we all know that API is we all know the acronym that it is it's an application programming interface. So when we say an application programming interface, like, what exactly it does. So it's like, as per the computer programming, if you look at it, it's some set of protocols and some set of subroutine definitions we give it in your API, and we tell okay, this is how my software looks like. This is how my software should do. When I instruct something, I should get the data like this. So that is what now we have it in our in the API. So a lot of details we'll probably give there, like what protocols it support. And when it comes to the HTTP world, we have a lot of protocol, like a lot of methods we talk about. How it works and what kind of protocols it should allow, a TCP, IP, or HTTP, and things like that. So API exists everywhere. So what I mean to say is, when you talk about something on a Google Docs, or sorry, not a Google Docs, if you talk about Microsoft Word or Microsoft Excel or anywhere you see, we have APIs everywhere. So under the hood is also using APIs, but not necessary to be on the web. When we have something on the web, we won't call it as we call them as an API, but it will be called as a web services. Now, how it helps in terms of the building software applications, APIs. APIs basically help you. It does a lot of heavy lifting, as I mentioned. Like, if you see in the slide, we're saying it does a heavy lifting of data transfer from client to the server. So if you look at a typical application like Amazon.com, you log in and you make a request. The data goes to the server and it does something, and whatever the request we send it basically understands that there is a genuine user coming up, and it takes some data from you and it processes it, and it says, okay, I found the response, and take it back. But the heavy lifting, the entire operations, the transfer of the data from the client to the server, and in between there is a lot of other application service, web service, some kind of other middle layers we have, and all that is basically happening by the APIs. So APIs does a lot of work for you. Now, we can we build an application without API? Yes, you can build an application without API. But the thing is, you have to manage a lot of business logic, developing business logic, or handling the business logic in your server side, or either in the or you're in a client side. So there's a lot of things you have to do. So which is like not so it's a not so good solution to design that way. So API is like, okay, when I design an API, when I'm developing an application on the website for a web application, I can also leverage the same APIs for even for the mobile-based applications. So an API can really leverage, in all kind of platforms. And especially in terms of the data, as I mentioned, like you can do a lot of data processing. You can, all the server side processing, will happen at the client's backend side or server side, and it's sent back and authenticate. A lot of rules we can, you can set up in the API, in the application programming. These are the APIs. Now, so we also say that it is it's like a contract. Okay. Yeah, thank you. So I keep getting some alerts, so I'm just checking. Yeah, thank you. So it's like a contract. So when we say it's a contract, in the sense, when we talk to another software, so there is like when we build this application, when we build a software, we have like species of blocks talking to each other. So when we write something on the client side, we use some of the frameworks like Angular, React, or anything. And we may use some API as a middle layer. We may develop some Node.js services. We may have DBs, so databases, and something on the hosted on the cloud or on-prem and all that. So every piece of software need to communicate to each other. So how do they talk? So we should probably come to a common agreement. So that is where we are talking about like a contract. So in any API world, for example, if you're talking about an API, when I say I wanted to go fetch some data from a server, so server says, I cannot understand whatever you just send. I only need the format in this specific way. I wanted like, you send me a username, you send me the client or the the date and the user authentication details, something like mask details and all that. Only then I can understand. So there is a format, there is a structure, what the other software is expecting you to send it. So that is where it's like a contract. We have to send a contract to by for one software to another one. Now, it's an interesting analogy. I just put it over here. We call it as, what exactly, the API, in a REST API service when we say. So you walk into the restaurant and you sit on a table, and you'll be sitting on a table, and you means is your client, okay? And you sit on a table and you say, okay, you want to order something. And what you're going to do is, okay, you look up the menu and say, okay, I want this, and you shortlist some items, and you call the waiter. And you tell, hey, waiter, can you get me these items? So I'm interested to have some nice, some burgers, or French fries or something. And the waiter takes your order. He makes a note of your items. Excuse me. He makes a note of your items, and he will go. He'll make once he make a list, and he'll probably. I'll ask you if you need anything else, but that's not going to happen in the API world, of course. Yeah. Now you make a list of the order, then you go and you tell to the chef in the kitchen, or kitchen is like a server, that okay, these are the orders I've got. So we need to these orders to be ready. Now, if you dissect all these scenarios, this entire story or the analogy which I'm talking about, so you is a client. I mean, you as a person, you go sit on the table, you are a client. And now waiter is like an API. So waiter is doing a heavy lifting there. So you don't have to expect a chef running out of the kitchen and say, yes, sir, what do you want to order? So he won't do that. The server won't come to you like that. So, I mean, a kitchen chef or someone, or a chef won't come to you like that. So you have somebody is doing the heavy lifting. Somebody is doing the job for you. An API, that is where we're saying a waiter, and will do the job. Like he'll take the order and go and inform the chef and say, this is the order, we need to get it ready. But if you look at it, he will, the waiter, he or she, we're just taking as a he, he'll take an order in a very specific format. He'll probably have these days we have like, iPads, or, an Android tablets, and he'll make a note of in there, and there is probably an app or something, and they'll make a list of all the orders, and that's the way they will do it. But if not app, if not a tablet, you can also put that in a piece of paper, but you have a structure there. You have a structure, okay, you cannot just write something. If I order something like a French fries, I won't say FF or something. If I wanted to order like burgers or pizzas or something, I won't write something as a P or P or something. I need a format, I need a specific structure for my server to understand. I'll just go and tell the server or the chef saying that, okay, PPFF and something. He won't understand. What do you mean by that? So you need a structure, you need a format. So that is where we have to call out, okay, this is what is a contract. The API says, okay, I'm going to communicate to these two agents, these two guys. So this is the format I need to follow. So that's simple as that. That's the analogy we're saying here. So waiter is an API, you as a person as a client, and the kitchen as a server. So as we go through these slides, we'll have the questions sometime in the the end of the session. We'll open the forum for these questions. You feel free to ask questions at that point of time. Let's moving on to the next slide. Now, where does this API fit? Like we know API testing is needed. We know we know about the what is API, but we have to test that API. So since we're talking about API testing, we need to know where this API fits in. If you look at this pyramid, this is what is our testing pyramid. We call that pretty standard pyramid. Everybody knows what is this all about, this pyramid thing. Now in pyramid, here if you see, we have a unit level at the bottom, we have an API somewhere in the middle, and we have a UI right at the top of the pyramid. So we all know that UI testing is also can be done, but it's pretty expensive. It's sitting on the top of the pyramid. There is a reason why it sits on the top of the pyramid, because it's expensive. It takes a lot of time for you to certify the build or certify any kind of testing, or sorry, any kind of UI testing. But you also have a unit testing. Unit testing is pretty much like, we all know that it's like testing the fundamental blocks or some blocks of code or functions or subroutines of a certain piece of software. And that is where the next thing is, you have a API testing. So this sits between the UI and the unit. So the API testing is basically like does the heavy lifting, as I mentioned. So this is where the API testing fits in. So it's not so heavy, it's not so light, but it does a good amount of job. Whatever the the API testing we want to do. You don't have to be so time consuming or resources intensive or things like that. It's a headless. I mean, we don't have any browser concept like that. We just have to hit an endpoint, get some request, and validate the response or things like that. So we want to know why we are showing this slide. Why we are showing this slide, just to let you know that the API testing sits somewhere in between the UI and unit test. It's not necessary to below the unit, but you will have it at the somewhere in between. So there are some kind of topics that, okay, we say it's debatable, okay, why you want to have an API at the middle. I can also do it at the lowest level. But API testing, we only consider the API testing in an integrated fashion. In an integrated manner, we want to test. Let's say there are group of services, or these days we have microservices, single service doing single job or doing one single responsibility principle it has. But it will help you to test the microservice very well, correct? But when it comes to the group of services talking to each other, that's where the integration happens. We need to test that. We need to certify how that API integration testing is really working well. So that is where we say that, okay, the API testing sits between the UI and the unit. Now, now we have to look at what is an API and what is a web service. So there are a lot of differences between an API and a web service. So there is a content, I put it over here in the slide. You can also read up a lot details, you will get it. But I want to bring in few important points, like as a QE or the QA, or it could be in any working on any platform, but you should know what is an API and what is a web service. So when we say web service, it's clearly calling out that is something happening on the net, something happened over the network, something happening over an HTTP protocol, anything over the network, be it as an HTTP, TCP, or any kind of protocol you're talking about, or FTP. So whatever is happening on the web, on the network, we call it as a web service. Now, all web services are APIs. So that's what we're saying. All web services are APIs, but not all APIs are web services. This is a very important point we should know. When we say all web services are APIs, in the sense, let's say we are doing some kind of, there is a REST endpoint, we hit something, we get the data. So it's like this happening over the network. So this is an HTTP endpoint we're doing. So we are hitting something, but it's over the network. So we say that that is a web service and it is an API. But it doesn't mean that the API should be always on the network. It cannot be. As I mentioned earlier, that if you talk about the Word document, or any desktop applications we have, like we have a desktop applications like Microsoft Word and Excel or PowerPoint or anything. I'm just taking an example of those. Under the hood, these Word documents and all talk to some kind of an API, some kind of APIs. We call it as a COM. COM means like component object model APIs. So, but these are not on the web. They are local. Like they're still APIs, but they're not on the web. But they're not called as web services. So I'll probably reiterate that. So when we have these Word documents on these spreadsheets, they all interact each other. They all work. When you click on a button, it does something. When you click on a new document, you see a new fresh document getting opened up, and you do some activity or create a table or do whatever in the Word document or in an Excel. But when we do some activity, there is something which is listening to such events. Your COM APIs, the component object model APIs are listening to such activities and responding to you as a client, and showing the whatever is supposed to do. So these are the APIs, but these are not sitting on the web. They are local. They're still considered to be APIs. So that's what we are saying. All APIs are not web services, but all web services are APIs. So that is what is the main difference is, we should know. Now, when I say, if you look at the definition we're saying, and an API is used to facilitate an interaction between two types of applications or softwares or things like that. So these APIs are again on the web, and that's why we call it as web services. Now, there is an interesting point I mentioned here. Web services are merely an API wrapped in HTTP. So it could be HTTP, it could be RPC, XML RPC, or could be any kind of protocol. So for simplicity, we are considering in all our examples as HTTP, just to understand hypertext trust and hypertext in a transfer protocol. So that's pretty easy way to understand this API testing and web services. Now, if you look at the last item, if I develop an application, so if I write some utility, let's say I'm writing a plugin to Excel, Word, or to Excel or a Word or any kind of desktop applications, I will be always using COM objects. I can give you a very interesting example. I'm sure pretty many of our people in our audience or in the participants in this forum probably would have seen QTP, HPUFT. So when we wanted to deal with the UFT, the internals, or like instead of you opening a UFT and trying to click a button, run and play, record and all that, you can also interact with QTP or the UFT so-called by using some of the APIs or the internals of that. So we call them as APIs, but they're not literally our APIs. We call them as COM APIs. We say component object model APIs. So these APIs, even if you have it, someone has to write the code to expose them to the outside world. There is another catch or the caveat to that. So we cannot just say that, okay, I have written APIs, I'm done. The job is not done there. You need to expose those APIs to the outside world. If I'm a user, I want to use the internals of the QTP or HPUFT, I should know what are the APIs. Someone has to really allow me or give me permissions to talk to them. So that is where we talk about this COM APIs. We should have those component object models, expose some of the sub functions, the subroutines, and you can use those APIs and you can deal with the application. So what we're trying to say is this is an API. So QTP or UFT APIs are being consumed there to do whatever the utility or do whatever the piece of software you want to develop. Similarly, DLL in C# world and C++ world, Microsoft terminology, we say DLL. So we have, you can use a DLL, it exposes something, you can do whatever you wanted. But under the hood, again, these are all the APIs, we call it as SDK or APIs. And jar file, again, in Java jar, like we in framework world, let's talk about an example of automation framework. So when we write automation framework, we expose those methods or some of the framework methods to the outside world. Somebody can directly take that and start consuming it and start building apps or building test cases. So that's again is possible by jar. Again, that's the API concepts are there, and that is where we're exposing these APIs. Now, there is the last one which we'll probably get into detail sometime later, but I'll just cover I'll talk a little bit about it. XML over HTTP, JSON over HTTP. So XML over HTTP, we all know it's an HTTP endpoint. You can get the response in XML. You can also have XML RPCs, the SOAP web services. You send it in a SOAP envelope and all. And pretty standard is JSON over HTTP. Like you send an HTTP request, you get the response in JSON format. So all these are again happening on some of the APIs which you're talking about HTTP, again over the network. Yeah, so what we learned is about API and a web service. All APIs are not web services. All web services are APIs. So that's a fundamental difference between these two. Okay. Before I go to moving on to the next slide, I wanted to share some interesting point about dissecting an API. So just one second. Okay. So yeah, let me stop my share and again share my screen. Okay. Yeah. Okay. So what I mean by the dissecting the APIs. So I want to talk a little bit about an API. This is something I learned from one of the Udemy, author. And it's pretty interestingly he, defined this thing, dissect the API. So I thought I'll probably, explain to the audience over here. So if you look at the API as an acronym, we have like an application and a program and interface. When I say in an application, it's like a software which is doing some task. So what kind of task? Could be anything. It could be any kind of task you wanted, what the software can do. When we say a program is basically what it does a task in the application. Hi, can you please go on mute, please?
Sai, I will mute them.
Yeah, I'm muted. Yeah, thank you. All right. Okay. Thanks. Yeah. Close. Yeah. Thank you. Okay, Kaja, you good? Can you hear me?
Yes, I can hear.
Okay. Thank you. Yeah. Yeah. Kind request, people who are not talking, please go on mute. So just don't want to have any background noise when we're talking. Okay, yeah, where are we? So we're talking about the dissect the API. So when we say API, we are talking about an acronym, and we say that there is a program and which basically does the task in the application, in whatever the application we have. Let's say I wanted to add two numbers, and we have written some program or a method, say, okay, do this. It just does the task, adding two numbers. And interface is like, we are telling, it's a place to tell the program to run. So I'll come to a real world application. So let's talk about Spotify application. So it's a very interesting example. Spotify, we all know, maybe Ghana.com or Spotify, a mobile application, or it could be even a web application, or web you're accessing via web. So for simplicity, let's understand that you've installed more Spotify, and you're telling Spotify is an application, is a software which is going to do some task. So what does a Spotify does? It just plays some music for you. You say something, okay, I want to play a music, it just plays music for you. But what is it does? When you say program, what is a program? It plays music. It's supposed to play the music. Okay, when I say click on a play button, it has to play the music, or it has to play what are the artist or the music or the type of the genre you select, and it'll play. But it doesn't do beyond that. That's what it's supposed to do. When we say interface, Meaning, the meaning says in place to tell the program to run. So when you say place could be like your mobile application, or it could be your computer or laptop, where you access the Spotify application via the web or the mobile. So you have a Spotify application. That is a program, that's a software. The program is to run the music. The interface is on your web application, on your mobile application, on your phone. You tell that to run that specific program to run. So that is what is, what is all about. Like you can talk about the acronym of this, the API. Pretty easy to know. Just for you to understand in your future. Okay, if somebody asks what it's all about, you can just take this, put this analogy, and you can keep that in your mind, and you can just relate it to whatever you see in API. And I given an example like a Word. Word is an application and it does some task. And when we do some kind of, we have this Word application installed on your laptop, and you do some activity. You want to draw a table, it does that. But where you're doing it on your laptop, or you're doing it on a mobile phone. So that is what is this, the dissecting, is all about. Pretty straightforward. It's like, you tell a piece of software to do something on a specific place. So that's all about this acronym. Yeah. Before we jump into the next slide, the sample GitHub APIs, I wanted to talk a few parts about this HTTP. We all know HTTP. Everybody knows HTTP. Even we are doing this Zoom application, Zoom meeting is also something happening on the HTTP. So there are a few parts which we all need to know, HTTP parts. That's what I'm saying. We have a start line, we have a headers, we have a blank line, we have a body. Now, when we say a start line, it could be like, a request line. What we do it on your request. Before we go to request and response, we all know that there are two entities in the HTTP world, and we have a request, we have a response. So there are two entities always. When you say something, it'll respond, back with whatever that is supposed to, whatever the request you give it, it receives, or it responds back to you whatever the request you asked for. Now, when we say headers, so headers are like, there is some kind of information you need to tell the server that this is what I'm looking forward. For example, we say content type. We'll get into some headers later point of time as we get into the Karate DSL, how we can specify these headers. But we all should know what is a header, because without knowing headers, we just put that and we don't know what it does. So we're telling that, okay, this is what I'm expecting, the header. Okay, this is what is the request I give, and the content types could be like many number of content types we have in the HTTP world. For example, application XML and JSON and things like that. Now, there is a blank line is also there. Now, what is a blank line is, that's like you'll be able to, there's one thin, like in a carriage written, like a new line. It's like it differentiates when the header is finished and when the body is actually about to begin. And this is happening like, in your HTTP world. And body, we all know body is like HTTP body or response body or request body. So there are a lot of types in that. We have an audio, we can have a image, JSON, HTML file. There are a lot of types you can give it in the body. It's not necessarily restricted to a certain type of format. We call it as a plethora of options you have it in the body. So there is a table down below. We are saying when we say a start line or a request line, we give it in the request. We also get it in the response, the start line and the response line status as well. We all probably get to see HTTP 1.1. That's the version we always see whenever we make any request. Probably would have logged into Amazon.com or any Flipkart.com. If you happen to see the network calls, you get to see these are the versions being shown there. Then we have like a methods. When we request these methods, HTTP methods, we only put that in the methods, but we may not get as a response. We get it in a different format. We get like a detailed response, but it's not necessary to be in the response. They should be in the request. Now, when we say API proc fold or resource means, if you see this one, like /search. So you have something called www.com, www.amazon.com and /search. So what does this means is the www.amazon.com is your domain, is the actual server, and the search is a resource path. So we probably get confused. Okay, when I say /search, we say we're just going to somewhere, but it's not somewhere. It is going to a specific resource. It's going to a specific folder location on the server. Amazon.com is your actual server. In that, you go to specific, once you get into that C drive, I'm just saying C drive is your location. In that, there is a folder called search. And in that, you're calling something. So that is what is actually happening when you say www.amazon.com and /search. So that's called as a resource path. And we don't get any response. We just give it in the request. And status code, we don't give it in the REST request. That's pretty obvious. We all know that. And we get the response and we get the status code in the response. 200 means, okay, all green, everything is okay, we're all good. So that's kind of an indication we say 200 series. Now, we don't give any format in the request. We get the format like this, a version plus status code. And that is what we see over here, like HTTP 1.1 plus 200 okay. So 200 series, I'll take a few minutes about these HTTP status codes as well. What is all about HTTP status codes? So anything with starting with 200 goes all the way up to 300 is good. 200 series means the request went through and is successful. 300 series, 301, 302, and whatever the status codes you have it, is also a very good response. I mean, I'm not saying a very good response. I would say the response is, the request is actually went through. You do not have to be concerned that, hey, the request did not go through. 300 series is all about like redirecting. Anything with respect to 300 series, like redirecting the user to somewhere else. Like let's say you hit a www.amazon. Something, like some specific domain name, and it's saying, hey, this particular page has been redirected to somewhere else. Then you get 301. But you still get the request. It's not cutting you off from the once you hit a wrong URL. So still you get the request. You still get the response, sorry. So anything with 300 is also good. Now anything with 400 series or status codes is something bothering. It's something you need to concern. You as a client need to be concerned. So what is that concern is all about? So when we say 400 series is, let's say we have 401, that means you're not authorized. We get, when you said unforbidden, you're not allowed to do that. You don't have access. So that means the server is actually working correctly. It says, I'm always healthy. I don't have any problems. It's you as a client, you're having a problem. I don't have any problem. So that's what the server says. So that is all about this, the 400 series. Even though you go to 401, not found, unauthorized, forbidden, authorization errors, all these is all something with respect to your auth related stuff, or it's something on the client side issues. So pretty standard, because I've been when I do interviews in just on a side note, when I do interviews, I probably ask people or the attendees or the interviews, someone who attends, and I ask them, do you know what does this mean? So it's not necessary that you should know what is a status code. You don't have to remember 401 is what, 402 is what, 403, but you just have one fair amount of idea. 400 means it's all with respect to error on the client side. You should know that. That's as simple as that. Now moving on to the last piece, that's 500. So 500 is all about like something happening on the server side. A server is saying, you gave me something I'm not able to understand. So that is what the server says. You gave me some request, but I'm sorry, I'm not able to process it. Server is erroring out. Server says 501, server says 502, or could be any kind of error. So what does it mean is server is unable to process the request. It says that gateway issues, or could be the moment you hit the request, the server went down, or you give something which is the program crashed. So you are safe. You as a client, we are safe in that regards. You can probably go and approach the person who has developed these services. You can tell, looks like there is an issue on your server side when I send this request. So The bottom line here is 500 is on the server side. Anything happens on the service is all 500 series issue in the status codes. So 200, 300, 400, 500 series. 200 is all good. 300 is also good. 400 series is the client side problems. 500 series is always on the server side problems. Yeah, this is a kind of a thumb rule. You can remember it. You will never forget it if you remember this one, and you can be clear on these concepts. Okay, moving on to the next slide. So this will be a kind of I'll talk about the APIs and I'll run through on Chrome browser, and I'll want to just show you what exactly these APIs are all about. Okay, let me minimize. I'll just copy this URL. Yeah, copy this URL and I say, I'll just put this my ID. So the moment I give this URL and I get the response like this, it's saying login, node ID and something, and I get some response here. So what is happening under the hood is it is basically making a call to the server and it gets me some data. So I'll just go back again. I've opened this developer tools just to show you what is happening, in actual, when we make a request. So never mind, I'm not able to see that. I think I should see San Maru here. Yeah. So when I hit this request again, so I'm getting 304, but it's 304 is still okay. I said anything with respect to 304 is like not bad, but it's actually green. And I told you earlier, 304, it's like any 300 cities is also okay. But if you go down further, you don't have any, query parameters. We'll come to there. So this is your server. This is your resource path. Under this users, I'm looking for another resource, another, or folder, whatever. We say users San Maru is your resource path. And this is your domain. This is your schema, or this is your protocol, HTTP or HTTPS. So that is what we see it in your HTTP world. Now you can go to the preview and you can see whatever the response we see it on the browser, we see the same thing over here as well, but more structured and more format. Like that's the behavior of your the Chrome browser, and that's what it's showing. So what you're trying to say here is, we make a request, you get the response like this. We get the response in a JSON format. By default, this API.GitHub always give the response in a JSON format. Now, if you go further down, we have some request headers. This we should know. We have like accept headers. It could accept any kind of headers, all these headers. And we will look at the language encoding. These are kind of important to know. Connection it's always be keep alive. And user agent may not be needed. So all we need to know when you're making an API call, that we should know what is the request URL and the request method, and we should know what are the headers we are passing. That is the request headers. So the request headers are like accept and the language. Language is not necessary. Mostly you can go with the accept. So some of the servers, when you make a request, some of the servers, they send you the response in a default format. Could be JSON or an XML. But it's always good to give the kind of the response you're looking forward. Now the next thing is, I will talk about another example in the same with respect to this. Now I can also get to know the list of repos I have. So I click on this, I get to see some repos. So here, this one is showing 300. You see this one? So I'll just bring it to the right so that for easy to understand. So here, yeah. So when I hit this request again, repos, I'm getting a 200. So this is like, it's a standard read-only call we made. An HTTP GET is always a read-only call. So remember that. Read-only in the sense you're not modifying any resources on the server side. So repos, Sanmaru, users, this is all the resource path. Like inside a user folder, there is a folder called Sanmaru. Inside a Sanmaru folder, there is a folder called repos. So we are always just querying it. Any number of times you query, we always get the same data. We always get the same data. There's nothing, wrong, in that. So these requests, we call them as idempotent. These HTTP GET requests are all idempotent. It won't change. It will never change. So because we're not modifying anything on the resources side. Now, as we see here, we have like same when we click on this, go to the preview, we have a lot of data. We have an array of objects here. Since you have a first object is like some data about the URLs and things like that. So everything it gives you, it's just a contract between the server and your client. I'm a client and I'm saying you take it and you take it whatever you wanted, and you can decide how we want to show that in your front-end application or whatever the web application you're developing. The bottom line here is we should know that the server is sending this data, and this is what is the response you get to see, and by default it sends in the JSON format. So here you may ask me that, okay, I'm not giving any authentication, but still is giving me the data. Well, some of the APIs are publicly exposed. That's why I said earlier, you need to have the APIs to be exposed so that the other piece of software or the applications can communicate each other. And if you do not expose, then it's no point of you calling it as an API. You can call them as an API, but you are not exposing it, so somebody cannot consume them. So these api.github.com, these are the exposed publicly. You can just give the users and whatever the user you wanted. You can also give the repos and you get the data. So these are publicly exposed APIs. Now, you may see that hey, I have like 30 rows or 30 elements I'm seeing, 30 objects. I'm not very keen to know 30 at the moment. I'm interested to know maybe the first 10 or maybe first 5. How do I do that? Like I'm very keen to filter my data. I'm very keen to apply filters on the response which I get it from on the client side or from the server side. So that is where we call it as query parameters. So what is a query parameter? So how do you give it? A query parameter is you can just say, okay, from the response you forget it, you apply some kind of a filters, and you retrieve the response matching to that filters, or you fetch the response matching to the filters. So let's look at the example now. So I'm going to do, one of an interesting example. This particular, user has a lot of repos. So for now, before I apply the query params, I'll take it out and I'll hit and see how many response he get, so how many records he'll get. Click on 200 and I've got like around 30. I think by default, this particular GitHub API is giving the 30 by default. There is like if you don't give any query parameters, or if you don't specify that I wanted some filtered data, the server will send you based on the filters which apply to the server side. That means server says you do not give any query parameters. That's okay. I'll send you by default 30. You take it or not. So that's the kind of server is saying. So it's like it's not saying that I cannot send you everything and sits on this user, but I'll send you 30 for my performance needs or whatever that the performance or not performance or whatever the software is designed, however the software is designed. But it is not saying that I won't send everything. I will not be able to send everything, but I'll send only the first 30. But I don't want 30. I want only 4. So here I'm saying pagination. We call it as a pagination in the in the GitHub API documentation. So when we say question mark, this is like a query parameter, query starting from page 1 and go all the way up to page 4. So we are saying per page I should see only 4. When I say give me the page 1, in that page I should see only 4 items. And when we see here, we have something called an ampersand. An ampersand is nothing but After this, I want to add another filter. So to associate multiple filters, we use a keyword or a symbol called ampersand. Now, when you press enter, you get some data. Now let's look at what is the data it has. Now, okay, just go back. Okay, yeah, let me close that. Yeah, now you see I have 4 elements here. It's very clear that I've got only four items from the server because I'm not interested in the whole 30, but I'm interested only in the first 4. So this data, once you get it, you are free to do whatever you want to do with the data. You can probably design some fancy web application. You can design some nice mobile SD or mobile app. You can consume these APIs, be it as a web or a mobile, anywhere, and you can use it for the client needs. So what you're trying to say here is, it's not necessary that you can just only give this kind of URL. You can also apply the query parameters or multiple query parameters. You can also just give like this, or you can just give anything you wanted. But sometimes if you just give some this kind of a garbage data or some random data, the server sometimes it will not it will not it won't complain. When I click on enter, it still give you the data. It won't complain anything because this is the last one. It ignores this kind of data. So whatever you give it at the end, sometimes it ignores. And sometimes if you give, there are certain applications, if you give some dumb garbage data or some unknown data, it says unknown request or something, and you have a problem. But some of the APIs, they will ignore it, or the APIs ignores on its own. Okay, so that is what we looked at. We looked at the pagination, we looked at the query parameters, we looked at the repositories, pretty standard GitHub APIs. Yeah, so this is a very interesting part. Now we'll move on to the DSL. So we talked about APIs. We talked about a lot about API testing, HTTP, and protocols, web services, and things like that. Now let's jump into the DSL because that's our main intent of having Karate DSL into our API testing. So what is the DSL? So we all know what the DSL stands for. It's a domain-specific language. Now, so as per the programming definition, it says that it is a kind of a journal purpose language. It's like an English kind of statements you write, and you're trying to solve some kind of a software problem. So that's what this Martin Flower. He's a good author on the DSL. He has written a good books. Feel free to take a look at it. His book, domain specific language. So it's pretty good books. It is. So a DSL is like you say some kind of a syntax when you talk about DSL. Gherkin is a DSL now, or XPath. The whatever we write in XPath in XML standards, XML language is also a DSL. We are saying 2 forward slashes star and at the rate ID is equal to something something. We say in Selenium world, it's actually some kind of a DSL to let the XPath to understand that the author or the user is looking for something from the in the document. So it is not necessarily limited to XPath. We also have these DSLs in many platforms. But the important point to have a DSL in your software or to your in your programming world is, or in your application or whatever you're building, is to let the non-programmers to understand what is it you're trying to achieve. For example, for simplicity, let's take a BDD. We all know, we would have probably heard of it. Maybe it is too early to talk, but just to give you an example, I'm taking this BDD. So when we say BDD, the moment we say BDD, we think about Cucumber, because that's a standard default or de facto standard. We look at it. That's a pretty good framework out there in the BDD world. So this BDD, you have certain syntax there. You have certain gherkin type of format you need to follow. Like we all know given, when, then, things like that. So only then the software or the under the hood, the application or the software or the jar file or the library can understand what exactly it does. Now, DSLs are kind of very easy to understand. The reason it's easy to understand is we say, given an application I log into this, I fetch something, I get some data or things like that. It's a very straightforward, anybody can understand. They're smaller because you'll write one line of statement, you move on to the next line of statement. And the main thing in DSL is it explains you the behavior of an application. That means when I go to google.com, when the user enters username and password or click on a sign in, it allows the user to log into the page or log into the, the Gmail application or Gmail, yeah, to the Gmail application or whatever we call it as. But we are defining a scenario there. We're defining that this is a behavior we wanted to see, that given this and this is what we go. The same thing in we can use these kind of DSL, the Karate DSL, we're coming there slowly, to write how we wanted to test an API, test any kind of line, or test when we say cucumber, we can also write DSL, Gherkin DSL to test a simple page or UI testing. We talk about that in later point of time. But DSLs are like very easy and a kind of trying to solve some specific problem in a more in English like kind of statements. Now there is a one statement, I just I pulled it from this, one of this book from Martin Flather, saying by exposing the real code to the people, you will enable more communication between the programmers and the customers. So when in a BDD world, we call it as a three amigos, in Cucumber. That's what the documentation says. That when you say three amigos means a product owner, a business analyst, and a developer, or business analyst or a tester and a developer. So product owner will write something, some kind of data or some kind of statements and say, as a user, as an anchor, I want to do this, I want to achieve this. When the user clicks on add to cart, the product should be, so when the user clicks on add product to the cart, the product should be added to the cart, and you just write like very high level, and this is what the product owner says. As a tester, we write the scenarios in a very easy way so that the developer like us or a QE can write the code for those, for those scenarios, we call it as. But what we are trying to solve here is this DSL bring in all three guys, all three, the programmers, non-programmers, or the business guys, stakeholders, everybody coming on one common platform. This DSL will solve a lot of problems. So we call it as TDD, we call it as BDD, or but TDD is like we don't have a DSL, but BDD is like we use this kind of DSL to improvise, to design the software more efficiently. But the same DSL can also apply in writing your test cases. That's what we're going to look at it. Yeah. So let's come to the karate. That's the main the intent of this program of sessions. Now, when you say karate, we all know that so many tools out there in the market. We all know Rest Assured. We all know that Postman is there. We have SOAP UI and many more tools like that. But these tools are like, they have their own certain amount of, limitations, I would say. Let's talk about Rest Assured, which is we all know that Rest Assured is like the standard Java's library we use to write our API testing, or API test cases. Now in Rest Assured, we have like we have to write the code like given when then we write some piece of a feature file. We have to write feature files. Then we have to write step definition code, and we need to write some kind of POJOs, plain Java, old objects, and things like that. So a lot of boilerplate code you need to write when it comes to the Rest Assured. For simplicity, we only take Rest Assured. We will not be able to compare. We are not going to talk about Postman, SOAP and all. Because Rest Assured is like we all know. That's the reason I'm taking that as an example and comparing it. And you can also take a look at it, the differences between the Karate and the Rest Assured later point of time. There is a link I'll give you in this slides, and you can feel free to check later point of time. Yeah. So Rest Assured has, you need to write code, you need to do compilation, should know how to write code in Java and things like that. Now, so there are other things in rest assured is like you need to know how you can have easily a data driven kind of testing. Yes, you have some options to do it, but you should also, rest assured won't give you directly like running the test cases parallelly just like that. You cannot just run it the way you want to run. I want to run these test cases parallelly. You don't have that option directly. You have to probably devise some new mechanism, new ways of writing some new law, some programs, or you're writing your own custom functions to do this parallelization. Reports, you don't have straightforward reports. Yes, you have TestNG, you have JUnit. You can plug it and you start running test cases. That will help. But the main concern or the main and the point which I want to emphasize here is you have to write code for everything. But when it comes to karate, now karate is not required to write the code. You don't have to write any piece of code. That's the beauty of this framework. It's an open source API automation framework. It's completely open source API automation framework. This is from the company called Intuit. And it's based on Cucumber JVM. And it will allow you to write API test cases in a Gherkin kind of language. It's called it as Karate DSL. That's why we talked about what is a DSL is all about before the slide. It allows you to write some kind of statements in Gherkin kind of format. We call it Karate DSL. And once you write those steps in a feature file, you click on run, and that's it. Boom, you're done. You don't have to write any step definition code. You don't have to write some tons of lines of code you have written in rest assured. So if you look at it, like any non-technical and technical testers can write in BDD style without knowing the code. It's pretty standard Gherkin syntax, like given, when, then, and you can just create the scenario. It's pretty easy peasy in that case, if you look at it. Now, the best part is, as I mentioned, you can write and execute the API test cases without writing a single line of code. So we'll take a look at an example as well. Yeah, as I mentioned earlier, some of the open source tools, we have SOAP UI, Postman, Rest Assured, and Postman is free. It has all the capabilities to develop and test APIs, but it's more of a developer oriented. Somebody wants to write API test cases, you should open a Postman tool, put your request response, and it's a more of a tool oriented, but it doesn't mean that it has no capabilities. It has very good capabilities. It has Newman, where you can use it to run it on as a CLI mode. And SOAP UI, it's an open source tool, but you have to use a tool, the desktop tool, to run your APIs. So we'll not get into the details a lot. So we'll quickly get into the next piece. Here is yeah. What are the challenges? I want to just talk a few seconds. With Rest Assured, you need to write step definition code, as I mentioned. You don't have a direct support for parallel execution. And with Karate, I'm saying there is no programming knowledge required. There is no compilation required. All of the above limitations can be overcome with the Karate. Now, why Karate DSL? So I'll talk a little bit about why Karate. Very few statements. So when we say Karate, as I mentioned, get rid of a lot of boilerplate code in writing API test cases. For example, you make a request, an HTTP request. For example, let's see this request. You make a request like this. You got an ID, you got a node ID, owner, and things like that. Now, I wanted to check at each and every record that this particular owner is having a title or is having a type called user. And it should not be, there should be a site admin, and it should not be a string, it should be Boolean. So I have these kind of validation to be done in my API testing. How do I do that? Yes, I can write in Rest Assured. I can use Object Mapper, Jackson, XML, faster binding. I write code in Java. Even I love to write in Java. So I write like, okay, read this tree, fetch this owner, fetch this object, and keep checking whether the site admin is false. But you're writing code there. Yeah, which is okay as long as you're comfortable. But we are saying that you don't have to write the code. This Karate DSL will help you to do all this validation and very easily. You can just tell Karate that go look at this piece of JSON structure and see that site admin is Boolean, it should be string, and things like that.
Sai, looks like there is one person in the lobby. Can you admit him?
Okay, okay. Yeah, I think, sorry, I just check.
Yeah.
Okay, one moment. Yeah, I keep getting those alerts, but I was not able to. Uh, where do I've admitted almost everybody. There is nobody now.
Oh, okay. Yeah, please carry on.
Uh, yeah, I don't see anybody. No,
I think that should be fine. Yeah, carry
yeah,
on,
should be
Sai. No
fine. Yeah,
problem.
all right. Yeah, thank you. Yeah. So, one second. Yeah. So, as I mentioned, that it's very easy to write API test cases without writing any amount of code, and no compilation is needed for this. It has a very good support for JSON and XML files. So we call, as per the community, they call it as a first-class citizens. So when we say first-class citizens, in the sense, you don't have to write any kind of parsers, additional parsers to read the JSON and XML files. As I mentioned earlier, that this is a JSON payload or JSON response, sorry, not payload, JSON response, and this is in a JSON format. Now, for us to read, as I mentioned earlier, that we have to write a parser, like you can download or you can use the faster XML or JSON or whatever the formats out there available. And you have to write code to read the structure or to read or understand the schema. But it is not necessary with Karate. You can just use this Karate the JSON and XML files directly without writing any additional passes. It's very easy. You can just say, go read this response, fetch me this dot owner dot admin dot something. It'll just go fetch the data. Even if you have a nested complex JSON or XML files, it will easily work. Some of the features I'll quickly run through is as I mentioned, it's Gherkin syntax, non-programmers can write. It supports various protocols, HTTP, HTTPS, and we have a JMS. It also supports event messaging queue and JDBC. We also look into this JDBC, writing a test case on JDBC later point of sessions, maybe in the future sessions. Scripts are pretty plain, no need to write any compilation, as I mentioned. And I would probably encourage to use an editor called IntelliJ. It's pretty easy. I'll explain that in a few seconds. Run all test case in parallel, cut down the execution time. That means um, you can run, Karate allows you to run all the test case in parallel. You don't have to write code how to run these test cases in parallel. It's straight out of the box available in Karate. And you can write complex request responses operations. I mean to say, you can make a request, you get a response, you can take the response and use it in the other request as well. Yeah, and the last one which I want to highlight is last part one is it can whatever the feature files or the scenarios you write, you can directly use it in the Gatling performance testing, Gatling tool for performance testing. And great documentation on GitHub. I think great documentation is not sufficient, but you should really take a look at the into documentation. It's amazingly the author and the community has written excellent documentation. Sometimes I think that okay, we should know a lot from there. Few differences with respect to the Karate and rest assured. Uh, a picture will give you a lot of information. So I'll just quickly talk about a Karate is this is what you write, and rest assured you just have to you write the feature file, you have to write scenario, you have to write given when then, you write POJOs, that is plain old Java objects, you need to write step definition code as well. But in Karate, I have to just write only the scenario given when then and I'm done. But here you're doing the exact you need to write the step definition code. Inside that, you're checking, validating the response and things like that. So this is where Karate stands out. You're just writing this feature file, but you're writing feature file, you're also writing step definition code. So that's where you see it in the rest assured. For a detailed documentation, for detailed differences, you can have a look at this link. This is given by the community. You can take a look at it in detail. Now, let's look at the how a Karate API test script looks like. This is the example which we pulled out from the GitHub documentation, from Karate GitHub documentation. We're saying here, given a URL, This is what is URL we say, and we say a request name is Billy, and we are making a post, and we're saying the status should be 201, and after that we're saying that the response should be something like this. So we're saying that you're hitting this endpoint, we're giving a payload like Billy in a JSON payload, and we're saying a method called post, that's it. And once we formulate this, and when we say that you make a request, I should see the response is 201. That's pretty straightforward, isn't it? Now, after that, we're saying match the response should be this. So the response should be like this. It should not be not null, and it should have the name called Billy. That's what we're saying in the payload assertion in one line. Now, the interesting part, as I mentioned earlier, that complex request and response operation. So you got a response from the first service. You can also use a part of the response from the first service as a request in the next payload or the next service. When you're saying response, we got response.id, I'm using that, and I'm making another call and checking whether the status is 200. So that's all about your Karate DSL, nothing much. This is all your API test case. No code, nothing, no compilation. We are done with this API test script. It's a very simple thing. Now, Karate setup, we'll first quickly go through some of the setup, like how we can actually create a Karate project. So let me open up terminal. Okay, so I'm here, I'll create some documents. I create mkdir training, cd training. Okay. Now here, I'll just put this, copy this. I may need to put it in a text pad because some new line characters are there. So what is this all about? Is how do I create a Karate, framework, or how do I create an archetype, a quick start guide? This is what the quick start is all about. Like we can create a frame or create a project, a Karate project. We're using a Maven. That's what the documentation, that's what it's been recommended by the community. So we're using Maven, and we are creating this Karate project by running this command. So we all know, we are not talking about a lot about the Maven, but I would encourage you to look at the Maven, Apache Maven software later point of time. It's a build management tool. It's a very good tool. Now here we're saying, this is where is the command I want to run, and I want to create a project called Karate demo. Now I'm going to copy this and I'll just say and paste it here. And I click on enter. Okay. So once again, I just have some new tab. Yeah, I did not expect that this will happen. I basically, just 1 second. Okay. So get info. Yeah, so CD. Yeah, say ls vd bin. Yeah, not there. Okay, looks like while changing my users, I messed up the editor, and I think that is the reason it is having a problem. Echo path. Okay, so I'll just do this for a minute and we'll get started. Okay. I just say m2 underscore home, and I'll just give this at the end.
Sai, can you increase the font?
Oh yeah, thank you. Yeah, thank you. Preferences.
No, you can press Command plus.
Okay.
That should,
Command. Is it better?
yes.
Okay, thank you. Yeah, so looks like I have a problem with the membian command. I think I something messed up while M2. Yeah, I'll just spend 1 minute and I see if it works. Otherwise, we'll go to the next part. Uses IM Marupa GSH command not found. Interesting. Okay. Okay, so let me do this last thing.
Sai, you are in Z shell, so you can do one thing. Um,
No,
I'm
I
just
did something like last minute. I don't know why I'm seeing this. Okay, let me do this way. Default login, I'll just do that and I'll quit this. Terminate, sorry, terminal, yeah. Okay, let me try now MVN. No, it's still the same. Okay, let's not waste time there. I will probably fix that later. Okay, so
or Sai, you can do one thing. Wherever that MVN is there, right? So you can just change your directory and run it.
okay, I did that. It's still giving a hard time. Yes, sorry about that. This shouldn't happen. I just cd bin ls. Yeah, I'm there. So I should say, let me copy the command again. Control A, Control C, Control V. Okay, I think that's fine, Kaja. Yeah. So I'm not sure why it is wrong. Okay, so I've already created the project locally on my folder on my machine, and I'll run through the structure, how it looks like, and then we will write a simple get test and we'll open for questions. So this is how, when we create the Maven command, we get to see the folder structure like this. Karate API testing, we have a SRC folder, we have a test folder will be created. It's pretty much like, we are going to write the test cases or the feature files in test folder, and that's how it looks like. And we also have a resources created, pretty standard format. And the important part, the point here is we get to see something called karate config.js file. So here, this file allows you to run the test cases like on a various platforms or various environments. If you have like a dev or dev URL or end-to-end, you can just customize it how you want to run. And we have a config file here where we can keep some authentication tokens and all. It's kind of a global, storage. And let's look at the very basic test case. As I mentioned, let's look at the get and post. And this is what is a get and post method. So this is what is a feature file, as I mentioned earlier. So let's look at this, the users. First, we try to test these users and the browser and see what is the response we get it. So when I just hit this, I'm getting this page, I'm getting this response. I got total 12 users, and this is what the 12 users are. Now, if I want to test this, this particular test case, if you want to write these, I'll go back to this and I'll write a new scenario. So I'll probably open up a new feature file. I'll just say new feature file here. It's not having a new feature file. I'll just copy and paste it. Yeah. Just say new feature file. Now it's fine. And just rename it as like rename, refactor, we just say as a simple demo get and post. And I open this and I delete everything and I just say, okay, this is a feature. And we're just saying training sorry, say a sample get call. Now, before that, before we write get the background, I just say given, or we just have to first thing is scenario, and we say verify verify that the users are displayed. Pretty straightforward. Now here we say given, and we're saying given a URL. So if you see here, when I type URL, I'm getting some of the IntelliJ assist or autocomplete kind of type assist thing. The IntelliSense will give you that. You can follow this and you can replace whatever you wanted. I would just say, I go back to the URL and just copy this. And here I remove it and I just say this like this. And I say, then when I make a request, okay, I make a request like a get, I make a request, then I say status is 200. That's all. Now I'm done with my test case. Now when I can just right click and say run this. Now let's see what will happen. Now this is all about your API test case. The very first test case is like writing a get request. That's all it is, nothing much. Now I just right click and I say run this feature file. I'll just say run this feature file. My script is running. It's Karate started. And sorry, it's when method. I made a mistake. It's not get. I always, okay. Save it. And again run. Yeah, so there you go. You got the test is passed. And let's look at what exactly it is telling. When you start the run by Karate, you can just right click and say run as a Karate scenario, or we look into the options of running from the terminal as well. We can also say Maven run command. But if you run from just as a feature file, what you see here is this is what is a get call made, and these are the response headers we got, and this is a request. This is a response we got from the particular from this endpoint. It also gives you a nice a report which you can understand in a lot detail. I'll click on this report and let me bring this guy down. Yeah, I'll click on this browser. It opens up a report. You see, this is what is the Karate HTML report you get to see. You can click on this, you can click on this, and you get to see what exactly happened. You made a request to this, and it says the method is get. It took like so and so milliseconds. It took like 0.7 seconds, and the response was 200, and it's all good. So there are no test cases failed, no test cases skipped, all are passed. You get to see each and every steps in detail over here. So the very first file, we call it as a karate config.js file, as I shown earlier. So we don't have any environment set up there. So my environment is empty here. So that is the reason it's saying it has no environment given, and that's why we say empty. So that's a default thing you get to see. Here you see given URL, your method a get, then you get the response as well. That's it pretty much. Now, let's also write another simple thing over here. Okay, I got the response 200, but I wanted to also check the response should be null. So I would say assert, I say response should be not null. Now what happens if I run this? Now let's see again. Yeah, so if the response is successful and you get to see, you get to see the HTML report again, we'll refresh this. You got the assert response is not null, so it is successful. Now, here we're saying we also get to see some other details over here. There were one feature file ran, the one scenario passed. We did not have any parallel execution because we were running in one feature file. That's the reason the thread is always one. So this is the details you get to see in the console, but not in the report. So let's look at the, let's add some more things to that. I'll just copy this line. So what are we trying to say in this thing is, there is an object called response. This response is a global object, okay? This response is a global object, and this has an attribute, or this response, if you go back to the URL or the data here, so we don't have, okay, let's look at the request.run, and we look at some of the list users. Yeah, you see, this is what we have. So so let me inspect that. I'll show you in a nice way. I just want to show you now. List users. One second. Yeah, I'll just probably copy this like this. Yeah. So ID data. How about here? Okay. So here we can see here. So we have a. Let me copy this. Copy and open up a JSON lint validator for us to understand, just nothing much. Okay, so this is a JSON response we get, and we have a data, and inside the data we have like a certain number of elements. We have an array of objects. Okay, so this is an object. You have an array here, the square bracket, beginning of square bracket, and you have an ending of square bracket, and we have an object here. An object has an ID and an email and a first name and last name and avatar. Now what we're trying to say here is, if you get the response, make sure that the data is having an array length of at least one object, and it should have an object. Okay, I'll tell the requirement again. The requirement says is the test requirement. When you get the response, make sure that the response data attribute is having is an array, and it should have a length of at least one element, or one, the size should be one, and it should have an object. So that's what we're trying to test it. Now in Karate, it's pretty easy to write. If you do it in Rest Assured, you need to write a lot of code, as I mentioned earlier. So let's look at how we can solve it. Now, as I mentioned, response is a global object. When you say response means dot data, means the moment you make a call, this call or this API request, you get the response, and the response will be stored in this variable called response. And you can directly refer that response object, and you can just say, get me the data. So this is the data, I get it. And this is a syntax you should know, how to check the length of the elements, or the how many number of elements I got in the array. It should be at least greater than one, and it should have an object, not a string, or not a number or anything else, so not Boolean. For us, since we want to test instead of saying object, I would just say string and see what will happen. I'll say number. So there are some kind of keywords or some